Another way we typically test the properties of logarithms is to maybe look at some true-false questions. So I have these four examples behind me, and these may or may not be true. So I want to explore them with you. This one states the log of 21 divided by the log of 7 is equal to log of 21 minus the log of 7. Well, this part seems familiar to me. If I'm taking the difference, the subtraction of these two, there is a quotient involved. But if you look at the property closely, the quotient actually involved inside with the two numbers. It's the log of 21 divided by 7, not the log of 21, then divided by the log of 7. That's a different setup. So at this point in time, I'd say this is a false statement. If I wanted you to make it true, perhaps the best way is to start with the part of the quotient rule that we can show. And I start with this part and say it's equivalent to a change of this. Let's let that instead be the logarithm of 21 over 7. See the difference? Log of the top number divided by log of the bottom number. This one is the log of the entire quotient. All right, so there's a big difference there. It's one of the common errors that occurs. Be careful. Secondly, I have this problem. A lot of powers going on here. 3 raised to the x, then the whole thing raised to the y power. Very interesting setup. If we take the power property of this expression, I would assume then that the power of this must come down off of the 3. So this would have to read x to the y power, not x times y. These aren't being multiplied in here. It's x raised to a power. So at this point in time, this statement also is false. And what an easy fix to be would be to change this piece. Instead, write this as x raised to the y power log of 3. Okay, so look at the next one. Down here I have the logarithm, the negative logarithm of m is equivalent to the log of 1 over m. This looks like the reciprocal property almost verbatim, just in different order than you saw last time. So the 1 over m is showing the reciprocal, therefore it's negative log m. This would be a true statement. And at this one, we have twice log 7, or 2 times the log of 7, equals a log of 49. At first glance, you might say, no, no way. But then if you look a little closer, this 2 is in front of the logarithm. So if I undo the power property of logarithms and bring this 2 back inside, I could rewrite this side as being the log of 7 squared. Well, the 7 squared is 49. So it's true that log of 7 squared is the log of 49, which is 2 times log of 7. True statement. Practice those and be ready for true false.